So far, we have only used pixels to size elements, but in CSS, we have quite a few units of measurement that fall into two categories, absolute and relative. Absolute units are always fixed. The value doesn't change. Examples of units in this category are pixel, which you have seen, point, inch, centimeter, millimeter, and so on. Now, the last four units you see here are mainly used in printing. They have no applications for the web. So let's get rid of them to simplify our table. Relative units are relative to something else. For example, we have percentages that are relevant to the size of the parent element. We have VW and VH, which are relative to the size of the viewport, and M and Rem, which are relative to the font size. What unit you use depends on what problem you're trying to solve. So let's see these units in action. All right, I'm going to start by creating a div with the class of box. Now, let's give this box a bunch of styles. I'm going to give it a width of 100 pixels, a height of 100 pixels, and a background color of gold. So here's what we get. The size of this box is always the same, no matter how big the screen is. So if you view this page on a small device like a mobile or a tablet, our box is going to stay at the same size. We can verify this by resizing the browser window. So look, our box is staying at the same size. For this reason, some people argue that we should never use pixel values because they are not scalable. We cannot use them to create web pages that are responsive to screen sizes. Well, I disagree. Pixel values definitely have applications. For example, let's give this box a top border. So we're going to set the border top property to 3 pixels solid orange. Take a look. I want this border to always be the same size no matter how big the screen is. So if you view this page on a wide screen, I don't want this border to look really thick. I always want it to be 3 pixels tall. So this is one application of pixel values, okay? Now let's talk about relative values. So I'm going to change the width of this box to 50%. That means 50% of the width of the parent element. What is the parent of this element? Well, here in the markup, here's our box. The parent element is the body element. But look at the styles we have applied to the body element. The body element currently doesn't have a width. So let's give it a width of 300 pixels. That means our box is going to be 150 pixels. Let's verify it. So here's our box. Let's inspect it. Now we go to the Computer tab. Down the bottom, look at the width property. It's 150 pixels. So all these relative values eventually get converted to pixel values by the browser, okay? Now, what if we remove this property? What is the default width of this element? Well, the body element is a block level element, and by default, the width of block level elements is 100%. That is why the stretch to take up the entire available horizontal space. So our body element takes up 100% of the width of the page, and our box takes up half of the page. So here's what we get. Now you might be wondering why we have some space around the box. This is the result of the margin property that we applied to the body element earlier in the course. So if we comment this out, now the space is gone, and the box takes up exactly 50% of the page. Now here's the interesting part. If we resize the browser window, our box also gets resized. This is the benefit of using relative units. With relative units, we can create layouts that adjust to screen sizes. With relative units, we can create more scalable layouts, okay? Now, what if we want this box to take up the entire available vertical space? You might say, well, we can set the height to 100%. Well, let's see what happens. Where's our box? To explain the reason, I'm going to create an empty div. So right after our box, I'm going to create an empty div. Now, let's inspect this div. So inside the body element, here's our empty div. Now look at the dimensions of this div. It's 550 pixels by 0. Now on your machine, you're probably going to see a different width. 550 is the width of my browser window, okay? But what matters here is that the height of this div is 0. So by default, the width of block level elements is 100% and their height is 0. If you add some content inside these elements, their height will increase to fit the content. So if we type hello here, now look at the height of our div. The height has increased to 18 pixels, so we can see the word hello, okay? Now, Let's remove this div. We don't need it anymore. Back to the problem. We are saying the height of this box should be 100% of the height of its parent element. Now, the parent element, which is the body element, currently doesn't have a height property. So by default, its height is going to be 0. Now, in this particular example, the only absolute unit we're using is for the border top property. So the height of the body element will increase to 3 pixels, and that is the reason why we see the border but not the box. So how can we make the box take up the entire available vertical space? This is where we use viewport units. With these units, we can size our elements according to the width or height of the viewport. So I'm going to replace the percentage with VH, which is short for viewport height. So this unit means 100% of the height of the viewport. Now, take a look. Our box takes up the entire available vertical space. And if you resize the browser window, our box also resizes. Now, similar to VH, we also have VW, which is short for viewport width. So 50 VW means 50% of the width of the viewport. Now, we get the same result as before. Our box is taking 50% of the width of the viewport, okay? So let's remove this comment. We have two more relative units called M and Rem, which are relative to the font size. We use these units in situations where we want to adjust the layout according to the font size. For example, if the font becomes bigger, we want the width to increase as well. So if we set the width to 10M, some people call this EM, you can call it whatever you want. It doesn't really matter. 10M means 10 times the font size of the current element. What is the font size of this element? Well, this element currently doesn't have a font size, so it's going to inherit the font size property from its parent element, which is the body element. But the body element doesn't have a font size property either. So it's going to inherit the font size property of the HTML element. All browsers give the HTML element the base font size of 16 pixels. So 10M means 10 times 16 pixels, which means 160 pixels. Let's verify this. So let's inspect our box. And here in the computer tab, let's look at the width property. That's 160 pixels. So in this case, our box inherited the font size of the root element, which is the HTML element. If we set the font size directly here, let's say 20 pixels, then the width is going to be 20 times 10, which is 200 pixels. Let's verify it. So look at the width, it's 200 pixels. So this is how the M unit works. But there's a problem with the M unit. If we don't have an explicit font size on this element, we have to trace up the inheritance hierarchy to figure out what font size will be applied to this element. Sometimes this can get pretty complicated, so that's why we have another unit called rem. So if we change this to 10 rem, that means 10 times the font size of the root element. Now, what is the font size of the root element? By default, is 16 pixels. So there's only one number that we have to remember to calculate the actual length. We don't have to walk up the inheritance hierarchy, okay? Now, what if we set the width to 15 rem? That means 15 times 16 pixels. In this case, again, the calculation is going to get complex. So let me show you a cool trick. On the top, we can define a rule for the HTML element and set its font size to 62.5%. That means 62.5% of 16 pixels. Grab a calculator, do the math, you're going to get 10 pixels. So if we set the font size of the root element to 62.5%, that means whenever we see a value like 15 rem, we can assume it is equivalent to 150 pixels. So we multiply it by 10. That makes our calculations easier. So here's our box. Look at the width. It's 150 pixels. Now let's see the benefit of the rem unit in action. Here on our markup, let's add a paragraph with some dummy text. Very simple, okay? So here's what we get. As I told you before, the default font size that the browser gives to the HTML element is 16 pixels. Now, some users change the default setting and increase or decrease the default font size. For example, here in Chrome, we can click on this icon, then go to Settings, and search for font size. So take a look. The default setting is medium, which is recommended, that is 16 pixels. Now, if you set this to very large, our text is going to get larger. Look, our text is larger, but so is our box. So if you have larger text, our box also expands to show more words per line. This is the benefit of using the M or rem units. Similarly, if we change the font size to very small, both the box and the text are smaller. Now look at the final code. In this example, we're using 3 different units: rem, VH, and pixel. So there is no such a thing as the best unit. What unit you use depends on what problem you're trying to solve. In this example, we used pixels to have a fixed size border. We used VH, so our box takes up the entire available space vertically. And we used rem, so the width of this box adjusts based on the default font size.